All right, I'm going to go through and show you how to do this assignment using the calculator features that I talked about in the previous video. So part of this is understanding what kind of test it is, and the calculator can actually help you with that. So more than 50%, found that 54 out of 100. So when you start looking at this, if you just start clicking on, okay, like is it one proportion or two proportion? Well, you don't have two separate samples, so that's not going to be helpful. If you're like, oh, is it a t-test? Well, you don't have a mean, you don't have a standard deviation. Like this can help you figure out what kind of test this is. This is one proportion. They want to know, is there convincing evidence more than 50%? So the null would be 50% of the students. Here, out of a random sample of 100, 54 supported the change. So 54 is an integer out of 100, more than 50%. So the alternative would be that the proportion is greater than 0.5. You can use the calculator, the draw feature. Calculate looks like this. There's your test statistic. There's your p-value. So your test statistic is z equals 0.8. Your p-value is 0.211. You'd fail to reject the null. You could be making a type 2 error. If you want to do the draw feature, I got to get rid of that box plot. There's your sampling distribution, your test statistic, your shaded area. So your test statistic and your p-value. That just gives you those two things. Okay, let me turn these off. All right, for question number 2, calculate a 99% confidence interval for the difference in the mean price. So these are two independent random samples. This is not paired. This is quantitative. So this is going to be a 2-sample t-interval. So 2-sample t-interval. I don't have all of the data, so I'm not going to choose that option. I'm going to choose stats. So I'm going to call this group 1. I'm going to call this group 2. So I'm doing US minus Japan. So for the US, the mean was 4.53. The sample standard deviation 0.24, sample size 15. And for group 2, Japan, sample mean, sample standard deviation, sample size. Confidence level 99, so 0.99. We're never pooling, and calculate. You're not going to get the draw feature for confidence intervals. Boom. Confidence interval, here we go. 0.11661 to 0.92339. That's it. I need to incorporate my degrees of freedom. As I mentioned on the previous video, I'm just going to round. Your degrees of freedom for any 2-sample test or interval will not be the same as we did in class. In class, if you're doing this by hand, you take the smaller sample size minus 1. If you're doing it on the calculator, don't do that. Just spit out the degrees of freedom that the calculator is telling you. That would be it. All right, for question 3, confidence interval for the true mean. Okay, so it looks like it's one sample or paired. We just have one sample. So this is a 1-sample t-interval. So I'm going to go test. There is no 1-sample t-interval listed in here. So I'm just going to choose t-interval. That's 1-sample t-interval. We do not have the data. I don't have anything to put into a list. So I just use the summary statistics again. The mean was 5.4. The standard deviation was 1.6. They surveyed 40 professors. Confidence level 0.95. I'm going to calculate. So here we go. 4.8883 to 5.9117. You'll notice here there is no degrees of freedom spit out. For the 1-sample t-test and t-interval, it won't. You have to understand for this, it's just your sample size minus 1. But hopefully you put that in the plan step. So, all right, there's the first 3. Let's keep on trucking. All right, 4. We got another confidence interval for the... Okay, so this we're doing a confidence interval for the change in the proportion. So it looks like either a 1 or 2 proportion Z interval. So I got to take a look. Was there 1 sample or 2? Independent surveys. So we have a 2012 sample, 2016 sample. So again, if you thought this was a 1 proportion interval, you're going to notice there's not enough information here. So this is indeed a 2 proportion Z interval. Okay, so in 2012, 10 of the 10,000 cars sold were electric. In 2012, now we have 100 of 20,000 cars sold were electric, and now it's got to be way higher. All right, 95%, 0.95, calculate. Just remember, these have to be whole numbers. All right, that's it. Your confidence interval, negative 0.0052 to negative 0.0028. And I did 2012 minus 2016. So make that clear in your plan step or your state step, the way you're doing the subtraction. Make sure you plug it in the calculator accordingly. Otherwise, it's going to be backwards. All right, for number 5, we're looking at a test. And let's see, I see units. I'm thinking quantitative, so I'm thinking T. We have a random sample of 10. All right, it looks like just one sample T test. They want to know if the salary is greater than. All right, so we're going to go in our calculator, stat test. There's no one sample T test, just T test. That's a one sample T test. We don't have the individual data to plug into a list. We have the statistics. Your null is this 45,000. The sample and the mean and standard deviation was found. Well, I'm going to write this in and then I'll put it on your sheet because you need those to do this test. So the mean is let's say the mean was, let's say, 46,890. And the standard deviation will go with 528. So the sample mean, 46,890. Sample standard deviation, 528. And they sampled 10 graduates. The alternative, we believe it's greater than this 45,000. Calculate. Okay, so I made this up, but I'm kind of glad I made it up in this way because you can see your test statistic. Your t-value is 9.36, which is extremely unusual. And your p-value, please do not write 3.1. Your p-value can't ever be greater than 1, so you have two options. 3.1 times 10 to the negative 6th in scientific notation. Or you could say the p-value is approximately 0, since the p-value is incredibly small. Either one is okay. I showed you the draw feature. If you do that, it's only going to give you your test statistic and p-value if you prefer that. All right, question 6. Calculate the test statistic and p-value. Chi-squared test. Is there an association? We only have one random sample. So remember, homogeneity has one variable, two or more samples, and independence is two variables, one sample. So this is a test of independence. The word association helps me with that. So I have to enter this data into a matrix. I'm going to go to edit. We have 2 rows and 3 columns. So I'm going to enter the observed counts from the table. Once you have those in, then you can go ahead and run the test. So stat test, just going to be a chi-squared test. Observed, expected, calculate. So test statistic, chi-squared is 1.40. Your p-value is 0.497. Your degrees of freedom for chi-squared, you're going to want to include those unless you know how to do those by hand, like rows -1, columns -1, but it'll spit that out for you. All right, question number 7. We're doing a test to see if the means are dispensing different portions of cookie dough. I see ounces, I see means, I see standard deviations. Now I just need to know, is it 2 sample or paired? There's 2 separate machines, and he takes a random sample of 10 from each machine. So they're not paired in any way. This would be a 2 sample t-test. So I'm going to go stat test 2 sample t-test. Again, we don't have the data. We just have the summary values, so we're going to do that. So if I'm going to do machine A minus B, then I need to make sure that A is group 1 and B is group 2 in the calculator. So put in my mean and standard deviation and sample size for group 1. Same thing for group 2. And the alternative, different proportions, or different portions, not proportions. So that would be not equal to. Never pooling, calculate. You don't have to worry about taking the area and multiplying it by 2. When you choose not equal in the calculator, it already doubles the area to get that correct p-value. So your test statistics about negative 1.73. Your p-value, don't write just p. Make sure you're writing p-value 0.102. And your degrees of freedom, as I mentioned earlier, for any two sample test or interval. There's just this crazy formula you don't need to know, but you just write down the degrees of freedom from the calculator. All right, last page. Okay, question number 8. Oh, is there convincing evidence that it would reduce the chance? So it sounds like a proportion. So it looks like two groups. There was a random assignment. So it's actually an experiment. Okay, randomly assigned to one of two groups. Half. So for the group 1, it's 500 was the sample size. They took a low dose aspirin, so low dose, it looks like 15 out of the 500. And for the second one, 26 out of the 500 developed colon cancer on the placebo. So this is going to be a 2 proportion Z test. So 2 proportion Z test. Just to remind you, these have to be whole numbers. If they said like a 14.3% of the 500, you'd have to multiply it and then round that to 72 in that case, but they just give us the counts, so we don't need to worry about that. So the way I'm setting this up, I'd have to do low dose minus placebo if I'm going to choose to plug it in that way in the calculator. They want to know, did taking the low dose aspirin reduce the risk? So this would be the smaller. So this would be less than 0. So it'd be less than that second group. You can calculator draw. So your test statistic is negative 1.75. Your p-value is approximately 0.04. So you'd reject the null. There's a chance of making a type 1 error. Your results are significant. All right, question 9 and 10 is kind of a switching gears. They're not tests and they're not intervals. Just a review of binomial that we haven't talked about in a bit. How do I know it's going to be binomial? A couple things. BINS, there's 2 outcomes, success and failure. Each trial is independent. There's a fixed number of trials, and the probability of success is constant. Words like at least, at most, exactly, 3 or more blackjacks. So if they play 20 times, and we're talking 3 or more, it would be that. So I have to do 1 minus binom CDF here. So in the calculator, 1 minus, this is under second VARs, binom CDF. Trials, you're going to have to label these N. N is 20. The probability they get blackjack is 0.045. And the X value is how many successes we're talking about. We need to subtract away 2 and below. So this is going to be X equals 2. So 20.045, 2, paste. This would be 0.059. So there's about a 6% chance of that happening. All right, question 10, exactly 3 puppies. That's a hint that this is probably binomial. I would go through bins and check. So now this is just going to be a binom PDF. N is 100. They looked at 100 dogs. P is 0.03. And they want exactly 3 successes. So X is going to be 3. You have to label N, P, and X. Otherwise, you're looking at a partial correct. So second VARs, binom PDF, 100.033. Hit enter. And you're talking 0.227. So hopefully you feel way more confident as far as doing confidence intervals and tests on your calculator. At the end of the day, for a test, the do step can simply be the test statistic and the p-value. If it's chi-squared or any kind of t-test or interval, make sure you have degrees of freedom, and that would be essentially correct. And for a confidence interval, you could literally just put the confidence interval for your do step, and that would be essentially correct. Again, if it's anything with t-test or t-interval, make sure, well, t-intervals, you have your degrees of freedom. If you got questions, let me know. All right, see you in class.